Hello, so today's video is basically a continuation of yesterday's video. So we just want to basically come up with a rule of how you can quickly determine the asymptotes of a graph that looks like this. So if you've got a graph that looks like y equals a number plus this kind of function here, so a number over something x plus something, what are its asymptotes? What is a quick way that you can determine the asymptotes quickly of a reciprocal graph like this? So that's our question for today's video. So if we go to the next page here, so I've just written out the graph again, the equation of the graph. So there are always going to be two asymptotes. Let's just make a note of this. So there will be two asymptotes with graphs in this form, of course. With other graphs, more complex graphs beyond A level, you can obviously get as many asymptotes as you want, really. But yeah, with these graphs here, you always have two asymptotes. So for the first asymptote, well, we know the function is not defined when this equals zero because you're going to get a number over zero, which is undefined. So if we just rearrange this, we get cx equals minus d, and then divide both sides by d, we get x equals, divide both sides by c, we get x equals minus d over c. So that's our first asymptote. So you have an asymptote when x equals negative d over c. Now, how about our second asymptote? So what I've done here is I've just taken away a from both sides to get y minus a equals b over cx plus d. Now, if we just swap that denominator for this number there, so basically just cross multiply, kind of, we get cx plus d equals b over y minus a. So when is this not defined? Well, it's not defined when, so undefined when y minus a equals zero, because obviously, again, you can't divide by zero in maths. So in other words, again, when y equals a, so this is our next asymptote. So basically, yeah, if you have a graph that looks like this, so a plus b over cx plus d, your asymptotes will always be these two results here. So your asymptotes will be y equals a, and your other one will be x equals minus d over c. So for example, if you've got the graph y equals 7 plus 3 over 4 minus 2x, then your first asymptote, sorry, let me just put a box around here. So your asymptotes for this, so asymptotes, so you're going to get 1 when y equals 7, so that's your first one, and you're going to get 1 when x equals negative d. So our d in this case is the number 4, so it's the constant corresponding to the d there. It's a number 4, so it's going to be minus 4 over the c value. So the c value here corresponds to the minus 2 there, the minus 2 coefficient. It's going to be minus 2. So basically, minus 4 over minus 2 is just the number 2. So when x equals 2, so we get two asymptotes, x equals 2 and y equals 7. And of course, we could use the previous video to help us sketch this. And it's going to be this example here is going to be one of our negative reciprocal graphs. So it's going to have a negative upside down shape because of that negative coefficient here. So if we go to the next page, this is just a reminder from the last video. So when c is a positive number, this coefficient there, we get a positive reciprocal shape. So this shape like that. And when c is less than 0, so negative, we get the flipped upside down negative reciprocal shape. So I mean, with this example back here, actually, I'm just going to make this writing all smaller. So with this example here, the actual sketch of this graph, we can actually just do this right now. So the sketch of this one down here, you've got y equals 7 as one of your asymptotes. So y-axis there, put 7 there. You have one asymptote definitely there, and then you've got one asymptote x equals 2. So you've definitely got one asymptote there, and it's a negative shape because our c value is less than 0. So therefore, it's going to have this negative reciprocal shape, something like this, and it will look something like that, and have a y-intercept there when the x value is 0. So when x is 0, just work this out very quickly. Y is going to be equal to 7 plus 3 over 4 minus, 2 times 0 is just 0. So basically 7 plus 3 over 4, which I think is 31 over 4, I want to say. Yeah, I think 31 over 4. So we get 31 over 4. That is our y-intercept there. So yeah, so again, it's just worth noting that the shapes will depend on this coefficient there. And also, we know the equations of the asymptotes will be always y equals, so I'll do this in red. So y equals a, and also x equals minus d over c. So that will always be our, they will always be our two asymptotes for equations in this form.